Let's find the local maximum and minimum values and saddle points of our function. So we have our function f of xy is 6 minus x to the 4th plus 2x squared minus y squared. Let's find partial derivatives. This is going to be negative 4 x to the 3rd plus 4x, and this is going to be negative 2y. Setting both of them equal to 0 is not hard, actually. This is an easy one. This gives you that y is 0. And let me make sure I did my partial derivatives correct. So this is constant minus 4x cubed, 4x, that's correct. This is with respect to y, so it's, yeah, that's correct. This is y equals 0, and this is minus 4. We can get factor out a minus 4x, which is going to give you 1 x squared, so it's just x squared, right, minus 4x cubed, and then minus 1. So it's minus 4x cubed plus 4x. This is all equal to 0, so 0 product property, you can continue our work. So it's minus 4x is 0, and x squared minus 1 is 0. So it gives you a bunch of values. It gets you to x is 0. It also gets you to x squared is 1, which is x is 1, and x is negative 1. So these are the values that we get. We can put them all together and get a total of 3 critical points. So first critical point, second critical point, third critical point. So we have 0, 0, we have 1, 0, we have negative 1, 0. Those are the 3 critical points that we get as a result of finding the partial derivatives and setting them equal to 0. This is not like the previous problem where we looked at where we looked at analyzing a system, because this is like we have x, we have one variable, one equation, so we can find the values for x and y and then just put them together. But we have 3 now, so we have to analyze all of them. Let's find d of xy. This is going to help us figure it out. This is the second derivative test. So we have fxx at xy times fyy xy minus fxy squared. Fxy at xy squared, of course, but I'll write it. Xy squared. Let's find fxx at xy. Well, fxx is just minus 12x squared plus 4. Fyy is just minus 2. And then fxy is actually 0, because remember it's respect to y, treating x as a constant, so 0, 0. 0 plus 0, 0. So plugging all of it in, we have this is giving you negative 12x squared plus 4 times 2, negative 2 minus 0 squared. So we can go ahead and distribute. It's going to be 24x squared minus 8. That's pretty much d of xy. We can plug in our critical points, actually 3 of them. So we have 0, 0, 1, 0, and let me make some space for myself here. Negative 1, 0. So 0, 0 is just negative 8. 1, 0 is just 24 minus 8, which is 16. And then this is also 16 because negative 1 squared is positive 1. Now, since this is less than 0, we can immediately say that this is a saddle point. So we immediately know that the saddle point, we have a saddle point, and I'll write it somewhere here. So saddle point at 0, 0 That's our first thing that we can say. And then this is greater than 0, this is also greater than 0, so we have to move on to fxx at xy, which is negative 12 x squared plus 4, and fxx at 1, 0 is negative 12 plus 4, negative 8. fxx negative 1, 0 is same thing, negative 8. Since these are less than 0, we know that we have relative maximums. So relative maximum, since d of xy is greater than 0 and f of the partial derivative, second partial derivative with respect to x at xy is less than 0, we know, since these two conditions are met, we have a relative max at the points 1, 0 and negative 1, 0. But what are the actual values of these maximum and minimum points? Well, maximum and saddle points. So what's the function value? We have a saddle point at the location 0, 0, but what is the saddle point value itself? Well, we can substitute 0, 0 in to our function, so we just get 0, 0, 0, everything 0, 6. So that's where we have our saddle point at that function value. That's that function value represents our the function value is where we have our saddle point essentially. And so let's see. So this is the saddle point. This is where we have the saddle point, and this is the saddle point. And then f of 1, 0 is 6 minus 1 plus 2 minus 0. So that's 7. And so what I wanted to say again, I'm just going to reiterate, is that this is the saddle point, but this is where the saddle point is located at. So that's what I wanted to say. It's what I meant to say. So negative 1, 0 is going to be 6 minus 1 plus 2 minus 0, which is also 7. And so really we have two different locations where we get the same relative max. So at two different locations we get the value 7, which is our relative max. So this is the value of our relative max, and this is the value of our saddle point, and we're done with this problem.